by the year 1906 that the recordings are near identical, and hence it's possible that the Colaba Observatory could be shut down.
Recently, scientists have traced a secret hidden in the ionosphere beneath Antarctica's dazzling summers and icy winters. The day-night ionospheric density fluctuated despite being completely dark in the winter and receiving 24 hours of sunlight in the summer. The ionospheric measurements conducted over a decade at Bharti Station in Antarctica revealed a significant seasonal variation. The equinoctial months had the highest total electron count, followed by the summer and winter. This long-term research can aid in mitigating and understanding the impacts of the ionosphere on satellite-based navigation and communication systems. The high atmosphere of Earth includes the ionosphere, a slightly ionized region stretching between 100 and 1000 km. Because the magnetic field lines are vertical, in the polar regions, the ionosphere there is extremely dynamic and serves as a significant energy sink for space weather events and associated phenomena within magnetosphere-ionosphere systems. Due to geographical constraints and a scarcity of stations, Antarctica has fewer ionospheric measurements than the Arctic. A group of researchers from the Department of Science and Technology, Independent Indian Institute of Geomagnetism have looked at long-term seasonal ionospheric observations at the Indian Antarctic Station Bharti from 2010 to 2022, as well as solar activity that coincides with the sun's 11-year cycle. At Bharti Station, it was noted that although there was those solar incidents during the day in the winter polar nights, a daily pattern was seen, with the highest ionospheric density occurring close to local noon. Ionospheric density fluctuations between day and night were noted independent of summer's 24 hours of sunshine and winter's total darkness. Scientists explain the peak ionization results from conventional plasma from high latitudes moving through the atmosphere and precipitating particles. Additionally, at the Bharti area, the highest ionospheric density throughout the summer on polar days, summer days with 24 hours of sunlight, was around double that of polar nights. The Journal of Polar Science published the study. Long-term research of this nature will aid in comprehending and mitigating the impact of ionosphere on satellite-based navigation and communication systems. What are the essence of these findings? The study's conclusion have important ramifications for satellite-based communications and navigation systems. Comprehending these fluctuations can assist in elevating possible impacts on these systems, resulting from alterations in the ionosphere situated between 100 and 1000 km above Earth. The ionosphere is significantly impacted by the sun's 11-year activity cycle because the magnetic field lines are oriented vertically near the poles. It is very dynamic there. The ionospheric density has a distinct day-night pattern with a maximum around local noon, even though Antarctic summer days are always bright and winter nights are totally dark. Participle precipitation and passage of conventional plasma from higher latitudes are the causes of this phenomenon. The research highlights how crucial long-term ionospheric studies are to enhancing the dependability of technology reliant on ionospheric circumstances. The study, which was published in the Journal of Polar Science, looks at the temporal features of UV radiations that reaches Earth's surface during the sun's 11-year cycle and discovers a relationship between the strength of Earth's magnetic field and solar radiation intensity. The study concludes that the mean magnetic field of the sun, solar oscillations, and UVB-UVA radiation affect the temporal properties of parameters in the local atmosphere.